In this video, we're going to go over transformations. We are going to be either adding k to f of x or adding k with the x inside the parentheses. So these are going to be called transformations. So we're going to be doing translations and reflections on this unit. When we say that we are adding a value to x, that will move our graph left or right. If we add it to the outside, so we add it to the y, that will move it up or down, depending on what value we add to it. This will be called rigid motion. That just means that whenever we move our object, it won't change its shape. It'll stay the same shape. So our parent function, or preimage, is our starting point. So it's where our graph starts at x squared. X squared, if you made a table or if you used vertex form, it'd be at 0, 0. And it would open up. So this would be our starting point. We would always start at 0, 0. So whenever we are trying to identify the transformation, we want to start at 0 and say how far over and how far up or down it moves. For example 1, when we take out the vertex, we would get a positive 2, 0. So we would go positive 2, we don't go up or down at all. And then because of the squared, we know it's going to be a parabola. So when it asks for the transformation, it moved right 2. So you have to identify this on your assignment, how far over it moved. On this one, when I take my vertex, I get negative 3, 0. That means I go left 3, and it will make a parabola because of the squared. So it would be identified as left 3. On example 2, there's no number in with the x squared, so 0, comma, negative 4 will stay the same. I do not go left or right because it says 0 first, then down 1, 2, 3, 4, and it will open up because it is positive in front of the x squared. This graph was moved down 4, from 0, 0 went down. 0, comma, positive 3. So I would go 0, up 3, put a dot, and then I know it opens up. That means that I went up 3 units. On example 3, they make it a little bit harder. They have 2 transformations that are happening. I go negative 1, comma, negative 4 for my vertex, and because of the squared, it's going to be the parabola. So we're going to go left 1, 2, 4, and then it will make a U shape. There's my parabola. So I went left 1, down 4. And this would be your answer. If there's a graph, you need to graph it. On your assignment, some of them don't even have the graphs. So you would just find the vertex and say left 1, down 4, and you're done. You don't have to graph it if there's no graph or no grid. I take my vertex out and get a 1, 4. That means I'm going right 1 and then up 4. If there was no grid, I would not have to graph it, but because there's a graph, I have to. 1, 2, 3, 4, and it opens up. On example 4, you have to create the equation. So when I pull the vertex out, it's 0 down 3. So when I put it into my equation, I'm going to have a 0. Oops. And my negative 3 stays the same. If you don't like the way that this is written, you can write x squared with no number because it's a 0. Minus 3 is on the outside. Positive 2, up 1. When I plug it in, this is going to be a minus 2 squared and a positive 1. Left 1, down 4. When I plug it into my equation, this becomes a positive 1 squared minus 4. On the back page, I need you to cross this off and write k times f of x. This is the main one we're going to go over and then we'll be done. So whenever I have a negative 1 in front of f of x, I want you to think about this. My original graph, y equals x squared, opened up. But if I stick this negative in front of my equation, that is going to make my graph go down. So whenever I have a negative on any of my equations, I need to say that it is a reflection over the x-axis. So watch out for that on your assignment. If you ever see like y equals negative x plus 2 squared minus 4, yes, it did shift it, translate it. It went left 2 and down 4. But there's also this little piece that we have to remember. If there's a negative in front, that means there's a reflection over x-axis. So watch out for those on your assignment.